All right, so now that you know the line formula, we're ready to get down to business. The first thing you're probably going to see in organic chemistry is a class of compounds called alkanes. Alkanes are only composed of sigma bonds, also known as single bonds, right? Which means that this here would be an alkane. This here would also be an alkane, and anything that does not have any functional groups, like alcohol or like ethers, whatever it is, if you only see single bonds, you're dealing with an alkane, okay? Now, I don't really like to memorize stuff, and I guess sometimes you have no choice, and this is one of those times. You will have to memorize, when it comes to the naming issue, you will have to memorize, I guess, at least these 8 issues here. As you go through organic, you're going to have to name these compounds, and the good thing is, at least the beginning of the word will also be used to describe other compounds. And so basically you have meth, eth, prop, and but. These are the crucial ones. You have no way out of this just because these are the most commonly used. What do they really represent? Meth actually represents 1 carbon, right? So you're going to have 1 carbon for meth, 2 carbons for an eth, 3 carbons for a prop, and 4 carbons for a but. So methane, which is the alkane version of the meth, is just 1 carbon with 4 hydrogens attached to it, right? Now, what do you think an ethane looks like? Ethane would just be 2 carbons attached to each other, each with 3 hydrogens attached to it, right? So this would be the methane, and this would be your ethane. Okay? Now, why did I separate these issues here? Because, as I said, the meth, eth, prop, and but will also be used for alkenes, which are the double bonded molecules, alkynes, which are triple bonded molecules. And so as long as you know the beginning of the word, you should be okay. All right? Now, what do you think a propane would look like? Well, obviously, you're talking about a 3-carbon molecule, right? Butane, you're just going to add an extra carbon, so you have 1, 2, 3, 4. And there you go. You have a butane, all right? Don't forget, there's 2 hydrogens attached to this carbon here, which we're not really showing, as well as here. And there's 3 hydrogens attached to this carbon, as well as this carbon here, all right? So alkene is the simplest molecule you can ever find, and it's crucial for you to be able to name them, right? So you can keep going with this, right? If propane has 4 carbons, how many carbons do you think pentane has? 5, right? So 1, 2, 3, 4, 5. There you go. You have pentane. Hexane, you would just add another carbon so that you have 6. 1, 2, 3, 4, 5, 6. This would be your hexane, and so on. You can keep going with this. When it comes to naming alkanes, there's a certain pattern that you want to follow, okay? The first thing you want to do is to realize and recognize what the longest chain is, also called the parental chain, okay? Now, if we have a structure like this one, okay, the first thing you want to do, as I said, is to realize what's the longest chain of carbons that you can possibly get. If we start from the left, you can have 1, 2, 3, 4, 5, 6, 7. So 7 here is actually your longest chain. Why is that? Because if you were to start counting here, 1, 2, 3, 4, 5, 6, well, that doesn't help us, right? Because 7 is bigger than 6. And when it comes to a parental chain, you always want to find the one that's the longest, okay? All right, so let's start assigning numbers to these carbons. 1, 2, 3, 4, 5, 6, and 7. Okay, so our parental chain has 7 carbons, and so which one of these names here corresponds to a 7 carbon chain? Heptane, right? So what you want to do is you want to write down heptane. I have the best handwriting in the world, but you should do it. Okay, so heptane, right? This is the name of your longest chain. But this is not just a regular heptane. We actually have these things here which we call substituents, right? As you can see, they're not part of the 7 carbon chain. This and this are substituents, okay? Now, it's kind of interesting of how this all comes together, because when it comes to substituents, you're actually using pretty much the same pattern, except instead of calling it a methane or an ethane or a propane or a butane, you're actually calling a methyl, ethyl, propyl, and butyl. So for example, you would call this thing here, right, which ultimately only has 1 carbon, right? This substituent is a CH3. You would call this a methyl substituent, right? On the same token, this would also be a methyl substituent because it's composed of only 1 carbon, okay? Now, when it comes to the numbering, you always want to use the lowest possible number to assign the substituents, which means that you want to start counting from the side of the molecule that would give you the lowest number, right? If I were to start counting from the right here, I would have 1, 2, and 3. So my first substituent would be at position 3. Obviously, that would be wrong because we want the lowest number, which means that in this case here, we really want to start counting from the left so that our first substituent is in the carbon number 2, okay? Now, what you want to do is you want to write down where your substituents are. Substituent number 1, 2-methyl, and then you have another substituent, carbon number 5, which is also a methyl group, right? So now you need to combine 2-methyl, 5-methyl, and heptane. And how do we do that? How do we bring these 2 substituents and the parental name together? Very easy. You're just going to do 2, 5 dash dimethyl, because you have 2, heptane. And that's the final name of your molecule.